Hello students, today we are going to see the method of OLS in econometrics. We have population regression function as discussed earlier, and we have sample regression function. Now our main task is to estimate population regression function on the basis of sample regression function as accurately as possible. Now to do this we have two methods. First is OLS method, that is ordinary least squares, and second is ML method, maximum likelihood. Today we are going to see that how to estimate parameters on the basis of OLS method, that is ordinary least square. So method of OLS, we know that yi is equal to yi hat plus ui hat. That is, we are estimating the parameters on the basis of sample. So the error term will be equal to yi, actual yi minus the estimated yi, which is equal to yi minus beta 1 hat minus beta 2 hat xi. Now our main objective is to minimize this, right? That we have to minimize the error, but we have n pair of observations xi and yi, and we have to choose a sample regression function. Now we have to choose a sample regression function such that the sum of these errors is as small as possible. Now we can't minimize this. Why? Because here this criterion is not good. Why it is not good? Because here all the errors are receiving same weight. So to remove this, what we do is we adapt least square criterion. Where what we are doing is that sample regression function can be fixed such that summation ui hat square is minimized. Here what is happening is that errors becomes weight themselves. Now this is a good criteria. So now we have summation ui hat square is some function of beta 1 hat and beta 2 hat, right? Here different values of beta will provide different errors, different values of this summation ui hat square. So now we have to find beta 1 hat and beta 2 hat such that this provides us least summation ui hat square. So main objective is to find these parameters. Now now ui hat is equals to yi minus yi hat, which is equal to yi minus beta 1 hat minus beta 2 hat xi. So this implies summation ui hat square will be equal to yi minus beta 1 hat minus beta 2 hat xi summation square. Now differentiating. Now we are going to differentiate our objective summation ui hat square with respect to our first parameter, that is beta 1 hat. So this implies, now differentiating this with respect to beta 1 hat, we get 2 summation yi minus beta 1 hat minus beta 2 hat xi multiplied by minus 1, because here we have beta 1 with coefficient minus 1, this equals to 0. So this implies summation yi minus beta 1 hat minus beta 2 hat xi is equal 0. This implies summation yi minus summation beta 1 hat minus summation beta 2 hat xi is 0. This implies we have summation yi equals to, now this becomes n beta 1 hat plus, and this becomes beta 2 hat summation xi. Now this is called as first normal equation. This is called as first normal equation. Now we differentiate summation ui hat square with respect to beta 2 hat. Now this implies we have delta ui hat square upon delta beta 2 hat equals 2 summation yi minus beta 1 hat minus beta 2 hat xi into minus of xi equals 0. Now this implies we have summation yi xi minus beta 1 hat xi minus beta 2 hat xi square equals 0. This implies we have summation yi xi equals to, now this becomes beta 1 hat summation xi plus beta 2 hat summation xi square. Now this is second normal equation. So now we have two normal equations with two variables. Now here our variables are beta 1 and beta 2, because we are differentiating with respect to beta 1 hat and beta 2 hat, and our main objective is to find beta 1 hat and beta 2 hat such that this summation ui hat square is minimized. So now we are solving for beta 1 hat and beta 2 hat. So in matrix form we have these equation as n summation xi square into beta 1 hat beta 2 hat equals summation yi xi. Now we are converting here those two normal equations into matrix form. So now this implies that beta 1 hat will be equal to summation yi xi summation xi square upon with determinant of this matrix, that is n summation xi summation xi square. So this implies that beta 1 value of beta 1 will be equal to summation yi summation xi square minus summation xi summation yi xi upon n summation xi square minus summation xi का whole square. So this is the value of beta 1 hat, and similarly we have beta 2 hat equals summation yi summation yi xi summation xi summation xi square determinant of n summation xi summation xi summation xi square. So now from here we have we have to replace this. We have n summation xi summation yi summation yi xi. Now this is equal to n summation yi xi minus summation xi summation yi divided by n summation xi square minus summation xi का whole square. Now this is value of beta 2 hat. So now here we have seen that using the OLS method, what we have done is we have find values of beta 1 hat and beta 2 hat such that this minimizes summation ui hat square. Now what we'll do is we'll write the value of these beta 1 hat and beta 2 hat in deviation form. So from first normal equation we have summation yi equals n beta 1 hat plus beta 2 hat summation xi. So this implies beta 1 hat is equals to summation yi upon n minus beta 2 hat summation xi upon n. So this becomes y bar with that is mean of y and beta 2 hat x bar. So this is beta 1 hat equals y bar minus beta 2 hat x bar. Now putting this in second normal equation. So from there we have what? Y bar equals summation xi minus beta 2 hat from there we have what? We have y bar summation xi minus beta 2 hat x bar summation xi plus beta 2 hat summation xi square minus summation yi xi equals 0. So from here, now solving this, we have summation. Solving this, we have summation y bar minus beta 2 hat x bar plus beta 2 hat xi minus yi into xi equals, now we have taken xi common as here and summation common. So now this implies we have this equals what? Summation minus of yi minus y bar plus beta 2 hat into xi minus x bar into xi, this equals 0. So this implies we have summation of minus small yi plus beta 2 hat small xi into xi equals 0. So this implies beta 2 hat is equal to summation yi xi upon summation xi. So now from here we have find beta 2 in deviation form. This is beta 2 in deviation form. So in today's lecture what we have seen is we have seen the method of OLS and how to find beta 1 hat and beta 2 hat such that your summation ui hat square is minimized, that is the method of ordinary least squares, and along that we have also seen that how to find beta 1 hat and beta 2 hat in deviation form.